Okay, so now we're back with part 2, and this is where we are diving into looking at measures of variability. Now, keep in mind that measures of variability, at least what we're learning in this class, are only for interval ratio level variables. So if we look at what the code is having us do, first we are getting information for childs, how many children someone has. We're going to get the summary for this variable, the interquartile range, the variance, and the standard deviation. And remember, we can find the range from the summary command. We can take the highest value and subtract the lowest value. We're also going to do that for child ideal, the ideal number of children people think you should have. Hours 2, how many hours people typically work per week. And TV hours, how many hours of TV people typically watch per day. So let's run this chunk. Notice for everything, we're including the na.rm equals true, so the missing values get dropped and we can accurately calculate the measures of variability. So RStudio doesn't really separate it out nicely for us. So let me just quickly point out, this is for childs. Okay, so we see that for childs, the interquartile range, the middle 50% of the data is 3. The variance is 3.18 children squared, and the standard deviation is 1.78 children. So what the standard deviation is telling us is the spread around the mean, or the average distance of a typical answer of how many children somebody has is about 1.78 children away from the actual mean, which is 1.97. The range would be 8, our maximum, minus 0, our minimum, for 8 as our range. The next one is the ideal number of children. Okay, so people in the GSS were asked, what do you consider the ideal number of children for a family to have? And again, people can answer from 0 to 8. Here you see that the mean is 2.965. We have the interquartile range, which is just 1. The variance is 2.92. And the standard deviation is 1.70. And so we're going to want to think, about comparing, because that's where the strength of standard deviation and variance and so forth come through, is when you compare variables and look at what their spread is like. Then we had hours 2, and that's this set of information. So the average hours per week somebody works is about 39.2, median is 40, max is 89, minimum 0, so the range is 89, and the standard deviation is 13.6 hours per week. And then finally we have the TV hours variable, how many hours of TV you watch per day, and people can say anywhere from 0 hours per day to 24 hours per day. We have a mean of 2.971. Interquartile range, the middle 50% of the data, is 2. Our variance is 5.59, and again, that unit of measurement would be hours squared. And the standard deviation is 2.36 hours. So I've kind of told you along the way what the variables are, but I have a little warning here. Before you answer the questions below, make sure you look up the variables in the GSS Data Explorer so you know exactly what they are measuring, right? So if you, for example, didn't know what child ideal is, you want to go over to our GSS Data Explorer. You want to search variables, and you want to make sure you have the exact spelling of the variable you're looking for. It's CHLDIDEL. C-H-L-D-I-D-E-L. Whoops, typos, D-E-L. Ideal number of children. So the question is, what do you think is the ideal number of children for a family to have? And you can see they can answer anywhere from 0 to as many as they want, which they cap as 8 kids. Okay. And you could do that with any of the variables if you weren't sure what the question was being asked for that variable, or what units it was being measured in, or what have you. Okay. Is there more variability in Americans' ideal number of children, or in the number of children that Americans actually have? And what does this tell you about Americans' behaviors and opinions? Okay, so the ideal number of children is our second set, and we can see that the interquartile range is 1 compared to, for child, it's 3. The variance is 2.9 compared to the variance for child, which is 3.18. And the standard deviation is 1.71 if we round it, compared to 1.78, the standard deviation, if I misstated that earlier. So in all cases, the measures of variability are smaller for the ideal number of children than for the actual number of children that people have. So my answer here will be, there is more variability in the actual number of children that people have. The IQR, variance, and standard deviation are all smaller for child ideal than they are for child's. What does this tell you about Americans' behaviors and opinions? So we want to think about this, think about the spread of the data, and think about sociology. The answer that people give to how many kids they have is much more variable than the answers that people give to what they think the ideal number of children are. So if we're putting this into an answer about what does this tell us about behaviors and opinions, you could say something like, Americans seem to have more similar views about the ideal number of children than the actual number of children they end up having. For the ideal number, the mean is, scroll up here, 2.9, basically 3, and the standard deviation is 1.71. For the actual number, the mean is 1.9, and the standard deviation is 1.78. Whoops, excuse me, that's my screen protector for when my cats jump on my keyboard. The mean of the child's variable. People's behavior in having children varies more than their beliefs about the ideal number. Okay. And then, can you compare the number of hours spent working and spent watching TV? Which has greater variation? This is a slightly trick question. So the variable hours, hours 1 or hours 2? Hours 2 is hours per week, while the variable TV hours is hours per day. We could multiply TV hours by 7 to get the total number of TV hours watched per week. Okay, and so I'm going to actually do this. Let me insert a brief chunk. So we're going to go up to Code, Insert Chunk. We're going to do TV week, assignment operator, TV hours times 7. Then we're going to do summary TV week, na.rm equals true. And we're going to do IQR TV week, na.rm equals true. There, just make sure I have the right commands. Yep. There. TV week, na.rm equals true. And SD. Now, I'm realizing I made a mistake here, and hopefully somebody caught it out in the viewing audience, but we need to preface this by the actual data set name and a $sign. And for each of these, we also need to do that. We're creating a new variable in our GSS 100 data set. That is TV week, which is TV hours times 7. And we're going to do it here again. TV week, comma, na.rm equals true. Let's run this. Uh-oh. Because I don't have the 100, it's not running the command. So there we go. Let's try it again. Okay, we've got some error messages that we can ignore. But you can see the mean TV hours per week is 20.8. The interquartile range is 14. The variance is 274. And the standard deviation is 16.55 hours of TV per week. Hours of work per week has a standard deviation of 13.6 and a variance of 185. So we have a higher, there is more variability within the TV week variable than in the hours 2 variable. Okay? So we're going to make sure to save this by pressing our save button, and then we're going to knit it to Word. And then after we knit this document, hopefully it's doing its knitting down here. We're watching it. Yeah. After we finish knitting it, we're going to go back over to our Blackboard, go over into the week by week for week 7. Oh man, it logged me out. And upload your Word document here. There you go.